let's try and unpick AWS's machine learning. Hello, my name is Alex Does F1 Stuff and welcome to another random F1 episode. And in today's stats video, we are going to be doing something completely and utterly outrageous and utterly fictitious as well. We are going to try and unpick AWS's machine learning for their fastest driver algorithm. Now, I use the term unpicking extremely loosely as I'm not a data analyst. I'm not qualified as a data analyst. I am just a person that loves using Formula One stats and creating graphs, etc. etc. But I'm going to try my best to interpret how they have managed to come up with their results. So, a little while ago, Formula One uploaded an article by AWS explaining their new insight, firmly deciding who was the fastest driver in Formula One history, popping Ayrton Senna at the top, followed by Michael Schumacher, then Lewis Hamilton, Fernando Alonso, and Max Verstappen. Then, of course, there were some of those weird outliery ones like Jarno Trulli and Heikki Kovalainen, I believe, was in that list as well, which was a little bit interesting. Now, there was a video attached to this article which outlined how they went about this process. So they have looked at each and every single qualifying lap in F1's history since 1983. Now, unfortunately, that would have taken me far too long to look at every single session from 1983 for those 5 drivers, as we are only going to be looking at those top 5. But what I have done instead is just looked at each qualifying session, their fastest time for that session. They have also excluded any outliery races such as the rain affected ones. I have also done that, as that's nice and simple. They have then also created a complex web of teammate interconnections. I have not done that, as I've tried and I have no bloody clue how it works, no idea whatsoever, and I can't seem to get it to do what I want it to do. I have values for this web to go like 1 layer deep, so I know how against Massa, Alonso and Schumacher compared, as they were both teammates to Felipe Massa, so I know those 2 values, but from there, it's beyond me. I have no idea where to go. But anyway, into today's video, unpicking the AWS machine learning. The very first graph that I will pull up is my order instead. And it looks a little bit like this. The average time ahead of their teammates in all of their seasons. So we have Ayrton Senna at the top, then it's Michael Schumacher, then it's Fernando Alonso, then it is Max Verstappen and Lewis Hamilton in 5th place. So one key issue with this is only looking at the times where they were in front of their teammates. I'm excluding any times where they were behind so far. Now, obviously, this graph looks nothing like the table that the AWS Insights introduced. The gaps are far too big and it's the wrong order entirely for the top 5. So how can we change this? Let's take a little look at Ayrton Senna and compare him with all of his teammates. So here is the average advantage against all of his teammates whenever he was in front. He had an average advantage of 3.8 seconds over Nakajima, 3.4 for Dumfries, 2.1 for Cecotto, all the way down to just under 4/10 for Mika Häkkinen. But what about the times when he was behind his teammates? Let's have a look at what that would look like. So Senna's average time whenever he was behind, he was 6/10 behind De Angelis on average, 5/10 behind Cecotto, 3/10 behind Berger, 2.5 behind Prost, and 0.5 behind Häkkinen. So what I can do with these 2 graphs is I can mush them together to create Senna's overall average against each of his teammates, and that is exactly what I have done. And we end up with a graph that looks a bit like this. Nakajima stays at 3.8 seconds, and Dumfries stays at 3.4. However, Cecotto comes down to 1.7. Andretti stays the same, De Angelis comes down, as does Prost, Berger, and Häkkinen. Which means if we now compare Senna's overall average in front versus his overall average including the times that he was behind, we have a 0.2 decrease. Now this is ideal. We need this gap to come down as we need him to come closer to everybody else. So far, we're heading in the correct direction for unpicking this AWS insight. However, I know already, due to the assumptions that I've had to take, we are not going to hit it in the slightest. So let's apply this methodology to everybody else, and let's take a look at Michael Schumacher now. So Michael Schumacher's average time in front of his teammates against Harriletto, 2.009 seconds. Average advantage against Jos Verstappen, 2.008 seconds. Against Herbert, 1.5, all the way down to Felipe Massa, it was just over half a second. And then comparing that to his time behind teammates, he was 7 tenths on average behind Barrichello, 6 tenths behind Rosberg, 5 tenths behind Massa, and 1 tenth behind Irvine. And so mushing these times together for Michael Schumacher exactly like we did with Ayrton Senna, we end up with 2 seconds still for Harriletto and Verstappen. Herbert comes down to 1.3 seconds, Patrese and Brundle stay the same, with Irvine, Barrichello and Massa also coming down, with Rosberg on average outqualifying Michael Schumacher consistently. So what does this mean for his average in front versus his overall average? Let's take a little look at that. So his average in front was just over 9 tenths of a second, but including all of the times that he was behind, his overall average comes down to half a second. Now let's apply this to the next person in the list, and that is Lewis Hamilton. His average time in front of all of his teammates, just over half a second for Button, just under half a second for Kovalainen, 4 tenths for Rosberg, just under 4 tenths for Bottas, and just under 3 tenths for Alonso. Comparing this to the time spent behind his teammates, 8 tenths for Kovalainen, all the way down to 3.2 tenths for Valtteri Bottas. And once again, smushing all of these values together, we end up with 3 tenths for Button, 1 tenth for Bottas, under a tenth for Rosberg, under half a tenth for Kovalainen, and minus 1 tenth for Fernando Alonso. Every single one of Lewis Hamilton's teammate has outqualified him once. And so what does this do for Lewis Hamilton's average in front versus his overall average? Let's take a little look. So 4 tenths for his average in front compared to, 1 tenth, just over a tenth. For his overall average. Quite a big step down. And now to the next person in the list, we have Fernando Alonso. Alonso's average advantage in front of his teammates, 1.4 seconds for Jung, 1.2 seconds for Marquez, all the way down to 3 tenths for Jenson Button. There are lots of teammates there, and I've had to make the numbers a little bit small as they don't quite match up, or they start overlapping if I make it any bigger. But if we compare this to his average advantage behind a teammate, it is 7 tenths for Fisichella all the way down to Lewis Hamilton on just under 3 tenths of a second. And once again, mushing all of these together, we end up with still a 1.4 second advantage for Jung. Marquez's value has come down, but Piquet's and Grosjean's have stayed the same. And then Raikkonen's, Van Dorn's, Massa's, Fisichella's, Villeneuve's, Button's, Hamilton's, and also Trulli's values have also come down as well. And what does this look like for Alonso's average in front versus his overall average? So his average in front was 0.566 tenths of a second, whereas his overall average has now come down to just over 3 tenths of a second. And then finally we have Max Verstappen just to look at. How has he performed against all of his teammates so far in his short career in Formula 1? So Verstappen's average in front of his teammates, 7 tenths for Albon, just under 7 tenths for Gasly, 3.5 tenths for Ricciardo, and 3 tenths for Sainz. And then his average behind those teammates, 7 tenths for Gasly, 4 tenths for Ricciardo, and 3 tenths for Sainz, and Albon has never outqualified Verstappen. And then like with the previous 4 drivers, mushing all of those together, we end up with still a 7/10 advantage over Albon, but now a 5/10 advantage for Gasly, a 7/100th advantage for Ricciardo, and it was actually Carlos Sainz who had the better qualifying performance than Max Verstappen in their season as teammates, just by 7 thousandths of a second. So what does this do for Max Verstappen's average in front versus his overall average? So his average in front was 4.5 tenths, and it has now come down to 1.6 tenths of a second. So an extremely quick rundown of the data that I have managed to pull from the Formula 1 website so far. Now, it is obviously nothing at all to what the AWS machine learning algorithm has managed to do, as I am not a machine learning algorithm. I am just one bloke with an empty Excel spreadsheet and a lot of numbers on a website. But anyway, I've had my best go at adjusting my original times, which was just looking at the times in front, and we now have this lovely new graph here. Their new average across all of the seasons. Ayrton Senna is at the top, 1.4 seconds in front, then it is Michael Schumacher second, almost a second slower. And then we have Fernando Alonso in third place, Max Verstappen in fourth place, and Lewis Hamilton in fifth. So overall, I have completely failed. I have utterly failed. I couldn't have failed harder. I have not managed to get the correct order, the gaps are completely wrong, and it's just not gone to plan in the slightest. But I've had a hell of a lot of fun making this episode. It was so much fun just researching all of this information and just popping it all together into some nice visuals. But that is the end of today's random F1 episode. If you've got any of your own suggestions, please leave them down in the comments below and I will take a look and see what I can do with those ideas. And just lastly, before I leave, remember this is entirely fun and fictitious. This is not meant to criticize, this is not meant to glorify anybody's particular statistics or particular achievements. This is just an entire bit of fun. But with that said, that's all I've got for you today, guys. I hope you have enjoyed and I will catch you in the next episode with whatever and whenever I decide to make it. I'll see you guys then.